On November 2nd, 2025, a spacecraft orbiting Jupiter, ESA's JUICE mission, turned its eyes toward a visitor from beyond our system, the interstellar comet 3I Atlas. It was the first time in human history that a probe within our solar system observed, up close, a body that originated among the stars, a fragment from another sun, an emissary of an ancient place. By early November, 3I/ATLAS had already completed its passage around the Sun. On October 30th, it reached perihelion, its closest approach, coming within 210 million kilometers of our star. Now, just 3 days later, it was retreating again into the darkness. But the story didn't end there. The Sun had awakened something within it. Gases, dust, and heat, turning a cold interstellar rock into a glowing, dynamic comet. For astronomers, this was a rare moment to witness an object born under another sun react to ours. JUICE was never designed to study comets. It was built to explore Jupiter's moons, Europa, Callisto, Ganymede, searching for subsurface oceans and traces of habitability. Yet fate placed it in the perfect position for a different kind of discovery. At 778 million kilometers from the sun, JUICE could watch 3I Atlas at an angle no Earth-based telescope could see. It became our remote observatory between the planets, the only spacecraft able to view the interstellar traveler in real time. In the control room at ESA Mission Operations, the data stream began arriving early that morning. The first frames showed a thin, elongated streak, the nucleus of 3I Atlas. Its surface reflected faint sunlight, shaped like a spindle rather than a sphere, a geometry that once again defied our expectations. It was not a perfect ball of ice like the comets we knew. It was stretched, narrow, and irregular, perhaps sculpted by collisions in the disk of another star system billions of years ago. As the sun's heat reached it, 3I/ATLAS began to vent volatile materials from beneath its surface: carbon dioxide, methane, and cyanides. These were the chemical signatures that JUICE's infrared spectrometer was built to detect. But this time, something was different. The spectra showed a spike, a bright line in the near-infrared range, corresponding to no known molecule. It repeated across multiple frames, confirming it was not noise or interference. It was real, an emission from something never before observed in our solar system. Back on Earth, scientists at ESA's European Space Operations Center began cross-checking the data with the archives of Borisov and Oumuamua, the first two interstellar objects ever detected. Both had shown irregular behavior. Oumuamua had no visible tail, but strange acceleration. Borisov was a classic comet, yet with a chemistry far richer in carbon monoxide than anything local. 3I/ATLAS was different again. It had the brightness of a comet, the structure of a fragment, and the chemistry of neither. For hours, JUICE continued its scans. Every few minutes, the nucleus flared, releasing bursts of gas and dust that formed a delicate tail, stretching over 1 million kilometers behind it. Through the onboard cameras, it looked alive, twisting, changing, breathing. Each frame was transmitted back to Earth, traveling nearly 45 minutes at the speed of light before reaching the control room. Each photon, a messenger carrying the story of another world. Astronomers watching the live telemetry noticed that the brightness of 3I/ATLAS tripled over a single day. It wasn't a gradual process. It happened in a sharp, precise pulse, the exact moment the JUICE spectrometer began its observation sequence. For a few hours, the comet blazed 3 times brighter than expected, and then, just as suddenly, dimmed back to normal. Coincidence? Maybe. But in astronomy, coincidences often become mysteries. Scientists proposed several explanations. Perhaps 3I/ATLAS contained crystallized methane that suddenly vaporized as it spun into sunlight. Or maybe it collided with a particle or fragment in the solar wind. Others suggested a more subtle cause, a magnetic interaction, invisible but strong enough to disturb the dust field surrounding the nucleus. Whatever the reason, it showed that 3I/ATLAS was not inert. It was reactive, a dynamic traveler responding to a new star. By late evening, the JUICE team switched to high-resolution imaging. They captured what appeared to be ripples moving through the tail, waves of particles drifting apart and recombining. Models indicated this could be caused by charged dust grains aligning to faint magnetic currents. If true, it meant the comet still carried magnetized material from its birth system, fossilized magnetic memory from another sun. It's a poetic thought, that even across light years and time, a particle can still remember the field that once shaped it. Meanwhile, ground observatories in Chile and Hawaii confirmed JUICE's findings. The Atacama Large Millimeter Array detected faint carbon emission consistent with hyperactive outgassing. The Keck Observatory captured spectral flickering in the Blue Range, another sign of volatile jets. For a few days, telescopes all across the world turned toward the same point in the sky, a fading, glowing streak between the constellations Virgo and Libra. For the first time since it entered our solar system, 3I/ATLAS was the most studied object beyond Jupiter. The data flow continued into the night. Each transmission from JUICE was a thread connecting two worlds, a robotic probe orbiting a gas giant and a fragment of matter from another sun. For engineers, it was a technical challenge. For scientists, a treasure trove. For humanity, a reminder of how much there still is to learn. Over the next 3 weeks, JUICE continued periodic monitoring as 3I Atlas retreated farther from the sun. By November 25th, its activity had slowed. The once bright tail began to fragment and fade. The jets quieted, replaced by a dim, diffuse halo of dust. The comet was leaving us, moving outward toward the realm of Mars, and eventually beyond the reach of our telescopes. From the data collected between October 30th and November 25th, scientists began reconstructing the full encounter. They found that the material released from 3I/ATLAS contained a ratio of carbon to oxygen unlike any local comet, richer in carbon, poorer in water. This composition suggested formation in a colder, more distant region of another protoplanetary disk. It meant the comet may have originated around a red dwarf star, a small, cool sun, perhaps billions of years older than ours. If true, 3I/ATLAS was not just an interstellar traveler. It was a fragment of another planetary system, carrying chemistry from a completely different cosmic nursery. Each discovery led to new questions. Could these building blocks be similar to the molecules that seeded life here? If organic compounds exist in one system, do they exist in all? And how many other fragments like 3I/ATLAS are drifting unseen between the stars, waiting to cross our path? Astronomers estimate that at any given time, thousands of interstellar objects are silently passing through the outer regions of our solar system. Most are too faint to detect. But every few years, one ventures close enough to be seen. A messenger from beyond. By December, the story of 3I/ATLAS had already reshaped how scientists think about planetary formation. It proved that interstellar visitors are not rare accidents. They're evidence that solar systems constantly exchange material across the galaxy. Dust, rock, and ice travel between stars, connecting worlds in a slow, invisible migration that has lasted since the birth of the Milky Way. In that sense, 3I/ATLAS wasn't an intruder. It was part of a vast cosmic circulation, a thread in a web that binds one system to another. From its instruments near Jupiter, JUICE transmitted the final dataset on November 30th. The images showed a faint gray nucleus surrounded by a shimmering halo of dust, still visible, still reacting to sunlight, but fading fast. In the control room, engineers watched as the last frames arrived. No one spoke, because everyone understood what they were witnessing. This was the final look at a traveler that had journeyed for millions of years, only to pass through our neighborhood for a few short weeks. Then, it was gone. In the months that followed, ESA scientists began publishing their findings. They compared 3I/ATLAS to Borisov and Oumuamua and found each unique, as if every interstellar object carried its own fingerprint, a record of the world it came from. Each one, a story written in dust and light. And together, they tell us something profound, that our solar system is not isolated, but part of an ecosystem of stars, constantly exchanging matter and memory. When you look at the night sky and see a comet's tail stretching across it, you're seeing time made visible. Atoms that formed in other stars, now burning in sunlight billions of years later. That's what JUICE saw on November 2nd, 2025. Not a mystery, not an alien craft, but a cosmic memory, a fragment of another world carried across the galaxy to remind us how connected we truly are. The story of 3I/ATLAS isn't just about discovery, it's about perspective, about realizing that even in the emptiness between stars, there is motion, exchange, and continuity. That every collision, every fragment, every stray grain of dust is part of a much larger pattern, the story of the galaxy itself. And somewhere out there, beyond Jupiter, beyond the edge of sunlight, the traveler continues its journey. Cold again, silent again, carrying the signature of two suns on its surface, the one that gave it birth and the one that briefly illuminated its path. On November 2nd, 2025, for a few short hours, human eyes saw that moment, through the lenses of a spacecraft a billion kilometers from Earth. And as the images of 3I/ATLAS arrived, pixel by pixel, we weren't just watching a comet. We were watching a message written in light from somewhere far beyond our own beginnings. Because every time we look beyond the sun, we find a story not just about them, but about us. This was the day JUICE saw the interstellar comet, and for a moment, our solar system felt a little less alone.